The morning very comprehensively covered the entire chain that goes through to ensure that we reach the target for net zero and the various technologies that are evolving in those direction. We subsequently saw Mr. Milin, Dr. Gopalan, Mr. Rahul, all of them talking in terms of how the various technologies are evolving, especially in the storage side. I was heading renewable energy sector in Tamil Nadu in 2011 to 2015, and trust me, we discovered at that time how inefficient storage was and how costly storage was. When we were trying to roll out solar rooftops in the state, that's when, realizing the challenges with the storage technologies, we for the first time pioneered the net metering policy in the country, using grid as the storage for the rooftops. I'm extremely excited to see how much the sector has evolved since then. A lot of advancements have happened. I'll quickly start by requesting Dr. Jha to give an overview of why storage and what we need to do and why it is required, and then we'll move on with other speakers. Dr. Kaushal Jha.
So, good afternoon. Please, yeah. So, my name is Kaushal. I'm CEO of SEET and adjunct professor in IIT Madras. So, I'll take you through why we need energy storage system very quickly. So, the most important part for renewable becomes intermittency or variation in the generation side. So if you see, a day does not depends on us. It's by God. Sometimes we have cloudy days. Sometimes we have complete clear sky. And the one of the graph what we are trying to show you there, that's basically blue color. It's a clear day, and you see the solar is quite constant. It's increasing and decreasing. However, there is another day that's in brown color where we have a cloudy day. So suddenly you have the maximum generation and then you have a minimum one. So it's easy to follow that blue line. It's easy to control other subsystems on the blue line, but it's very difficult to control something on the brown line. Now this is for a day. Now if you look upon moving average of the week, over the year. So if you see the solar, you look almost like a constant. However, the wind is seasonal. Sometimes it's a very large, and then over the time, in some seasons you have very low. That's the main two sources. There are different other sources, but just for introduction, I wanted to take you to there. So the wind and solar depends on weather conditions and the time of the year. Now, there is another part on demand side. Our demand is also not constant. Sometimes we require some equipment to run, and sometimes we may not. And depending upon that, you also have several peaks in a day, and generation might not be in the same. If both follows the same curve, there is no issue. But generally, it does not follow the same curve. So what is the solution? So one of the prominent solution for that, I'm talking about to 70%, 80% or 90%. Maybe after that there could be some other problems. But for that, energy storage is one of the solution. But in that, if we have to look upon, what we have to look upon? A short term to meet the daily mismatch, and which can be easily computed based upon our day-to-day activities, day-to-day our energy consumption. The second one is the midterm, where it's not day-to-day, it's maybe week, it may be for a month. And the third one is the long-term storage, where it's based upon the season. Some season we have more renewable but less uses, and that time we have to use that, we have to store that energy to use rest over the year. And then other than these three, we have peak demands. That's a very short period, maybe 5 minutes, 10 minutes, 15 minutes time. So what we have been doing in the SEET is that we have developed multiple different types of lithium ion storage over the time 110 kilowatt hour, multiple pieces, then 50 kilowatt hour for the office complexes, and then a megawatt hour, couple of megawatt hour in a small string in parallel can make to a megawatt, 2 megawatt hour, 5 megawatt hour, such type of system which we have been working in the seat. We have been also working on other energy storage system like thermal energy storage. So where I don't need to convert the energy into the electricity directly. It could be used as it is. In that, even in thermal, we have sensible heating system, then we have the latent based heat system, and then we are also working on multiple other things for the long-term storage for the futuristic thing like zinc air, hydrogen, and the compressed air. Now, coming back to the peak demand, what we can do. So it adds significant additional cost due to the demand charges. So that's basically being taken by DISCOM. So relatively small, what we require is a relatively small storage, but should have a high power density. And that's why it should also have a good number of cycle life. And that is where we have also partnered with Log9 so that their developed LTO cells we can utilize to make a small battery pack and can give us around 100 to 150 kilowatt power at instant. So with that, I'm stopping my presentation. Over to you, sir.
Thank you, Dr. Kaushal. Very briefly but quickly, you have set the tone, and I'm sure everybody in the audience now clearly understands why the storage is needed and how it is required. Mr. Mahesh, I'll quickly request you if you could introduce yourself and then maybe share a couple of technologies that you think are going to be the future for storage in India.
So, good evening, friends. My name is Mahesh. I'm the founder and CEO of Kodi Energy. We are developing very novel technology, first of the kind in India. And we are the first in the country to manufacture the commercial grade lithium-ion cells with our own technology. And so far we delivered to 20 OEMs in India. So specific to the energy storage, the predominant market globally was run with majorly with LFP technology, because where you have both energy density, shelf life, and cycle life is higher. At the same time, Log9 is also working on LTO technology that also really good for the country like tropical countries like us. And beyond lithium, the next big thing is coming is sodium ion, because India as a country, we don't have the rare earth metals like nickel, cobalt, and aluminum, but sodium is abundantly available. So sodium going to play a big role, since stationary storage don't have the space limit, but however in the EV there is always a space constraint we have. So in that context, most of our stationary storage applications you see currently in India, a lower middle class to the upper middle class have lead acid batteries, right? So that is not good for environment, but however, we have the industry that is running successfully from decades. But sodium is going to play a predominant role for the stationary storage because of the, we have a lot of sodium available. And we as a company working at the materials level for the sodium-ion batteries. And we also developed our own materials for the cathode and electrolytes for the sodium-ion batteries. And we are going to do very big announcement early next year with our own technology for the sodium-ion batteries. While that I'm telling about our organization, it's not about us. This is the once in 100 years, the transition is happening from EV to, IC to electric vehicles, and less dependencies on the fossil fuels. And also, if you see, additional layer is adding on the grid is EV. So without stationary storage, a grid can't survive, and the grid can't supply to the electric vehicles. So and during the peak time, 6 p.m. to 9 p.m., right, where definitely there is no sun, very less wind is there as well. Wind also seasonal. So stationary storage play a very critical role, either it is LTO or LFP or sodium ion. All these things need to get into the mainstream. Okay, we have multiple technologies, multiple advantages, multiple disadvantages there. However, industry, academia, and government should play a very critical role. Why academia? Because we don't have the skill set for the resources in India. A lot of gigafactories are coming, a lot of research is happening, but where is the manpower we have? And that is what Rahul is doing very good job partnering with IIT Research Park and building up a curriculum. Like in my 2000s, computer science is like a very big, highly paid job. Nowadays, electrochemistry and also the chemical engineering, metal engineering, playing a very good role, and those are going to be highly paid jobs in next decade. So this particular industry is going to sunshine. At the same time, manufacturing, right? India is never a manufacturing hub, but 1.7 trillion worth of manufacturing is coming from China to India. In that context, cell manufacturing in various aspects of cell making, where we also need again a lot of manpower, mechanical engineer play a crucial role, instrumentation engineering play a critical role, and that ecosystem need to be developed in India as well. So with this, I want to thank Isa and also Professor Ashok ji on this initiation. Thank you.
Thank you, Mahesh. Let me come to Mr. Ravichandran. You and your company have a very vast experience over several decades on power side and power conversion technologies. So would you like to share insights on how that is relevant for the entire storage and renewable energy storage ecosystem?
I think the audio is missing.
With increased focus on climate change globally, there has been a shift towards green energy. Energy storage is the key to unlock India's ambitious target of achieving 40% of installed renewables capacity by 2030. Energy storage system accelerates the development of electrification, decentralization, and digitalization and relies on power conversion. Danfoss Drives has unparalleled expertise on energy storage systems, and we lead energy transformation using power conversion technology, which helps reduce emissions. The Danfoss campus in Varagadam, Chennai is a proud example of how Danfoss India walks the talk. Made a reality with our partner Sarah Inc., the campus hosts India's first privately owned and managed grid-scale battery-based energy storage system. A plug-and-play for both behind-the-meter and front-of-the-meter applications, the system is also scalable and flexible while providing a reliable and cost-effective solution. The energy storage system also helps to avoid energy wastage by storing an additional 270 kilowatt of excess energy generated over weekends. Our DNA and culture have been instrumental in building our leading position across multiple industries. Energy storage integration into its renewable energies is one of those top actions. Sustainability has been part of Danfoss's purpose since the company was founded. Driven by the power of an electrified society and fueled by the opportunities of going digital, Danfoss is engineering solutions that can unleash the potential of a sustainable tomorrow.
Thank you, Mr. Jain, energy storage, I think we still are, I would say in the early stage, but at the same time, we are at kind of between 2023 and 2030, we would see a huge amount of transformation on three areas. First is on the technology side. I think on the technology side, there are three things that I would like to mention. One is, as many of you heard, and you will continue to hear about the battery technology. That's not a domain area that I come from. The second biggest area on the technology side you will see is the proliferation of silicon carbide. Now, silicon carbide is a pretty interesting technology which will even push the envelope of energy efficiency to a higher level. The third important technology that is going to be proliferating in the energy storage is conversion of heat into cooling, which is using heat pumps actually. So these three technologies would, at simultaneously they are already in place, but they are, at a galloping speed getting onto scale. In terms of India, I think we already have quite a good experience on the silicon carbide, at least in the car industry. We've also had a lot of examples of silicon carbide used in power converters, but I still think the heat pump industry has to evolve as far as India is concerned. So that is one of the critical things that we believe we need to build the whole ecosystem. I think a lot of speakers have spoken about ecosystem, and this is one of the challenges. When we try to solve common problems, unfortunately, I am not from the tech side. I am from the P&L side actually. And in any business, end of it, we need to make money. So when you look at the balance sheets of many of these technologies, general payback time are between 8 years and 20 years actually. So we also need to keep in mind when we develop technologies, faster paybacks are also very important so that, our experimentation cycle can get very, very important. So that's the economics part of it, which I wanted to leave you all with. Second, on the battery storage, the regulatory framework needs to be, accelerated further. While India has the best policy on BESS, there are 3-4 things that has to unfold actually. One is we have a very ambitious goal of 450 gigawatt of renewable by 2030. We do not have a goal for battery energy storage. In my view, we should have a 5% target on the installed capacity that we want to do. So what this means is that if anybody is putting up 100 megawatt or a X megawatt, 5% should be mandatorily energy storage. It has to co-develop it. The reason I say this is quite a lot of battery storages today are directly connected to the grid. Solar plants are directly connected to the grid without battery storages. So what happens is, in India, we don't have a pricing differential on peak time. The maximum between states is about 20%. But when you look around in the US and China, if somebody wants to have a peak tariff, it's about 200 to 300% more than the normal tariff actually. So we don't have the luxury of that because 70% of our electricity is subsidized and industry pays for it or government takes it as a subsidy into the books actually. So we need to mandate a 5% mandatory battery energy storage as part of the integrated solar plants. This is one of the important things for the industry to take off. Second is, I think we also need, from the regulatory side, a lot of push on decentral solutions. Because decentral is what will take off battery storages quite a lot. And I think most of the states should come up with a lot of policy. Since you are sitting on behalf of Tamil Nadu, I would request that decentral power would be really the way to go for proliferation of more and more battery energy storages as well. The last one is, what I wanted to talk about is, when we try and solve one problem, we should not create another problem. And one of the biggest challenges in the industry, which we are sitting and discussing is, almost 90% of the raw material are imported, right? And even when you have to ship these materials, there's a carbon emission. And with European Union moving towards putting a carbon tax from 2025, life is going to be even more difficult for countries in the geopolitical world to fight for raw materials actually. So when we design systems and when you incubate a lot of technologies, we need to build the circularity integrated as part of the design principles as well. And this is very core to the future. You cannot win without circularity. Circularity leads to sustainability. And those companies who have embraced this in the design principles have started to see balance sheets becoming very attractive actually. So I will stop here with this, but I think I have a lot more to share, but I'll come back later if you have more things to share.
Thank you, Mr. Ravichandran. Very valid points. And the last one which you mentioned in terms of whether we are moving into technologies where almost solely we are dependent on imports as the inputs. Just to share with you, at Tamin, we have a very large graphite mine, the largest in the country, and the largest graphite beneficiation plant. But current technology, we reach only up to around 95% fixed carbon graphite flakes. We would definitely love to work with the industry to see how we can upgrade it, feed it into the lithium-ion manufacturing requirements. With that, I'll request Mr. Akshay, if you could introduce yourself and with the pioneering work that you are doing in setting up the cell manufacturing for the lithium-ion and other battery solutions. Could you share your thoughts about those?
Thank you very much. Thank you everyone for inviting me here. So I'm Akshay Singhal. I'm the founder and CEO of Log9. We are the company which has been pioneering advanced lithium-ion cell technologies in the country. LTO is something which we have deployed at large scale, which apparently was kind of demeaned as a technology a lot for a very long time. But we've been able to prove its worth, especially for the tropical world conditions that we see in India. And now going forward, we are looking at deployments across, we already do 2-wheelers, 3-wheelers and 4-wheeler cargo vehicles, providing battery packs for those. And now we are looking at larger platforms as well as stationary energy storage. As we do that, I would like to highlight a few things from an India perspective. What is that we need to have a sustainable energy storage or renewable energy transition in the larger scheme of things? What is important is to look at 3-4 parameters. One is, what are our operating conditions? Our operating conditions in India and neighboring countries is very different from what has been seen across US, Europe, China, Japan, and these markets where these technologies are at a much more advanced stage. Secondly, what kind of material availability can we look at, as other panelists also mentioned, in the long term? And it's not just about material availability, but also what stage are we at in terms of material processing and material beneficiation, if I can call it, to be applied into this industry, as we were just discussing. And he gave the example of graphite, that while it is available in large quantities in India, we are not able to process it enough for battery application. Similar is the case with so many other materials which go into lithium-ion and other battery technologies. For example, aluminium. India is the second largest producer of aluminium in the world, but we don't even produce an ounce of battery-grade aluminium in the country. So a lot of these supply chains need to be worked upon to kind of have a sustainable battery manufacturing and energy storage ecosystem to grow in the nation. And the third part is what we started with this, that the panel started with that discussion around what are our local weather conditions, local seasonality, and what kind of battery storage would be relevant for us to take care of the short-term, mid-term, and long-term gaps that we have in generation versus demand. So these things have to be kept in mind, but what we have to steer away specifically is not go or basically run behind what has happened in other countries, but to have a fundamental approach to problem solving in terms of what we need in the country. And that's the only reason I can take example of Log9 over here, where we have been able to analyze that what are the requirements, and instead of a lot of pushback from that LTO would never work in the country or in anywhere else in the world, we have proven it otherwise, and we have a large scale of LTO, and now we are looking at LFP also coming into the foray. So that is very important to look at fundamentals, that what is required, what can be delivered, and what is possible in the circumstances and scenarios that we have in our local market. And then we can, that's the only way to truly become a global leader, because you solve for your local requirements, you create a strong moat for yourself, and then it's an international market for you. So that's the approach that we are taking. Also on the point of different level of intermittencies, I would like to point out that while batteries make a lot of sense for short to medium term intermittency and fulfilling that gap. I think when we talk about long term intermittency, seasonality of solar wind production, it is important to look at more chemical technologies. For example, if we chemical and electrochemical in that sense, when we talk about hydrogen as one example, then we have redox flow batteries. We also have technologies, for example, aluminum air or metal air batteries, which are coming to the foray. And these technologies would also be important to make sure that whatever seasonality we have, particularly with wind and solar, we can solve for that. Another very underappreciated piece, which I have seen across various discussions that happen in this on this topic, is that we neglect nuclear as an option quite a bit. We have judged nuclear energy on the basis of a 70, 80-year-old technology and the kind of cons and the difficulties in managing that technology that existed. But today's nuclear technology has progressed significantly. It has progressed to a level where there are modular nuclear reactors that are possible and can be a reality very, very soon. You can have a DG set size of a nuclear module available, which can take care of your backup needs or any kind of energy demand gap that can happen at a local level or even at the grid level. And nuclear is the only technology or option which can give you ramp up or ramp down almost at a similar pace like you would see in your thermal power plants. So neglecting that whole domain, I don't think is the right strategy, not just for India, but the entire mankind. So we need to really relook at nuclear and see how we can double down on bringing it for taking care of the larger seasonality or the larger gap in the renewable energy generation. So that's where I stop.
Thank you, Akshay. Very pertinent point. And Professor Jhunjhunwala in the morning in his presentation did mention that modular nuclear reactors, small reactors, but very, very kind of guarded technology as of now. So not much understood and much known. But yes, it cannot be a neglected domain. We'll really lose out if we don't focus on it. I'm sure there are a lot of budding entrepreneurs, budding startups, as well as a few startups here in the audience. So from the industry side, from your insights, would you like to share one area where you would advise them to focus on as a startup, or any project that you would like to collaborate with them so that they can come with you and work on a specific technology or a specific project? So can each of you share one or two such areas? Mr. Mahesh?
Definitely there is a lot of improvements need to be done in the various layers of cell, either in cathode, anode, and binders and separators, right? So in that context, cathode play a very critical role, and it's a very costly component. So innovations in the cathode material, definitely we are happy to partner with academia and also startups where we can get the cathode that can be predominantly manufactured within India. An example is sodium-ion batteries, which is really important. At the same time, the other challenges we as an industry face is the foils, like we use a lot, like aluminum and copper foils, right? So till date, there is no industry in India that manufacturing a grade of foils we required. But what industry facing a challenge is they're not understanding how to get the purification quality for industrial grade. That is also good opportunity and big market is there. That also one of the interesting area of either aluminum or copper foils, and also separators. We as in India do a lot of paper manufacturing, right? So we have some other forms of paper industries there, and cellulose separators or any kind of separator technology, an interesting area. That's very focused, big market is there. And there are various components which, and also the other important, as I said earlier, is the skill development at the academic level, right? Even if you have any innovative thoughts, bridging that gap, that also really helpful for the industry as well. Yeah.
Thank you, Akshay.
So I would say one of the important aspects which a lot of work is required and can be done very, very effectively in India is around data collection and analytics on battery life, feasibility, safety, performance in the operating conditions of the country. Right, we have a lot of data which is available from other geographies, which is not directly relatable or applicable in the Indian context. So if we can have different teams which can focus on different types of chemistries, for example, different types of battery solutions, and how they perform in the Indian conditions, and how we can have predictive analysis on their long-term not only performance but safety and reliability.
Excellent, Mr. Ravichandran.
I think, combining fintech, battery design, and offering a business model which is storage as a service, especially in battery storage, has not really taken off. And there's a huge opportunity in this space for startups to come and disrupt. We have seen a lot of disruption in the solar PV in this business model, but battery as a storage business model innovation can be one area that can be looked into. Second, if somebody has a lot of interest on circularity, and that's an area where we are working quite a lot, making sure that we have end-of-life management. There's again a business model innovation needed. There's again a lot of chemistry and the entire whole life cycle of the raw materials that's going into the production of these silicon carbide to the whole system engineering. There's a lot more needs to be done on the circularity piece as well. And I think, lastly, I think there's really no limitation for deploying technology. But I think we need to also look at partnerships for meeting these goals. We can meet the desired goals actually. And that's why, in one of the sustainable development goals, the last one is about partnerships. Because partnerships are very critical to be more agile in the future. So I think there could be a lot of new ideas coming from the university on how can these partnerships can be more accelerated, between companies. And many of the companies are really very silos. They look into one technology, but end of the day, what you offer is a storage as a service, which is deploying multiple technologies. So I think partnerships is another area where there's a lot of work we can do. We are ready to work with some of you all who are keen on that. Thank you.
Some very interesting areas opened up to the budding entrepreneurs, budding startups. If you start working on even one of these and take it forward, you can see real improvements in that sector.
Generating energy is gravity. But the capex is very high. Until you have thousands of crores, you cannot set up that kind of thing. But gravity, like a mini gravity based energy storage system, right, where you get uphill, you flow the water and it will pump it back, right? It will go just going on circling the water. That is the most cheapest way. But however, there is a capital investment upfront is very high. That is my point of view. But more or less all chemistries, LFP, LTO, NMC, all this and 15-10% difference is there in every aspect, right? So it's based upon application, right? What application we use, it has its own advantages and disadvantages. But it is something like one shoe won't fit for everybody, one chemistry won't fit for every industry, right? So we need to see what is better at that application and take it forward. But every sector horizontally, vertically have its own market in India.
Your question, we'll take the question from the front row first, and then we'll come, somebody had raised the hands that side.
Good evening, I am Sheshadri from Saifuel, Hyderabad. I have done work on compressed air energy system. It can replace lithium carbonate in all the aspects. First is you can generate solar energy, and it all can be converted to potential energy, and with an impeller it can be regenerated back during non-solar hours. and it is very cheap also. And moreover, the electric vehicle also can be converted to electricity, and you can run the vehicle. So compressed air is not lost at all. The air is given back to the system, back to the atmosphere. So this is a very effective energy storage system, which is possible for our country like India.
Definitely looking forward, we are also based out of Hyderabad. Meet you and discuss about.
Particularly on compressed air storage, the thing is again application. So compressed air storage would work very well for midterm intermittency solution because the end-to-end energy efficiency of compressed air storage is less than 30%. That is the state of the art today. And from that perspective, if you have technologies which can give you a sub 10% energy loss in the cycle, then that doesn't make sense for a short-term storage. But long-term storage, you don't have a solution. So in the midterm kind of a situation, you can have compressed air storage. And again, long-term, the challenge is what kind of loss factor do you have on a continuous basis? How long can you store it for? That's where, as I said, based on application and utility, we have to choose technologies across the three verticals of energy storage.
He had mentioned hydro storage. Do you think tall buildings can be used for water falling and water being pumped up? And what kind of efficiency will we be able to get? It 15-floor building, 20-floor building, can we actually do that?
We definitely need to consider the environmental factors. It is not affecting any environment, won't damaging with that kind of activities. And all the environmental concerns, that's definitely an opportunity where you have your own campus, you can try it out here, and there are a lot of funds available for you to do it. Everybody can look into that one, yeah.
I just wanted to add one important factor is the round trip efficiency. And at least in the utility scale grid connected, our experience has been that we've been able to achieve 82% round trip efficiency. Of course, as the scale goes up, you may still go up from 82 to 84. But anything on that level, whether you bring in a compressed air technology or any other technology, round trip efficiency is a very important factor for us to make the right choices. But again, it's a system engineering, right? Like what Akshay said. The whole system has to be engineered in a right way. And there's no one size that fits all.
For paucity of time, we'll take just one more question. If anybody has any query.
And environmental concern, I'm putting this question. So everybody we are talking about the lithium ion batteries. To extract the lithium by refining that ore, we are spending a lot of money to extract that lithium into a product. Then how it could be, and lot of things to be invest on that lithium extract, how it will be, it is a green energy.
Yeah. Last 5 years of extracting the lithium ion, it usually used to take like weeks and months to extract the lithium, high purity lithium. Now it is get it down to hours. So that kind of efficiency and efficacy developed without contaminating the environment. And also new technologies are coming up in terms of the mining process and everything. The other important, definitely the urban mining, right? That plays a very critical role. And India is going to be second largest for the lithium ion consumer after China. In that way, recycling also good opportunity, but efficacy, efficiency, and without contaminating the environment, new technology evolved last 5 years, so that's not a big issue at all now. But 10 years back, it's a big problem. Now it's not at all a problem. Yeah.
So I would like to just one more point over that one. So it's not about only importing. It's also about recycling. And if we are able to recycle that and take it back, because lithium is not getting waste. It's changes its form, which is no more usable in the cell. But if we can get back that lithium, I don't think the shortage would be so hot. It may go for much longer time. So
Thank you. I think one last question.
Yeah, one straight, simple question. Of course, actually, levelized cost of storage depends on the application. In general, for large-scale application, what is your roadmap? I mean, how long is it going to actually take, and what needs to happen to reach around, let us say, 3 rupees per kilowatt hour levelized cost of storage? Do you have any projections?
So two, three things are important. Lower cost, lower upfront cost of the battery. So we are already talking about sub $100 per kilowatt hour kind of cell costs. Additionally, you will have to have system costs and everything in place. The second thing is life, increasing life, and then increasing that life in the tropical conditions. So those parameters are important to reduce the levelized cost of storage. The other thing is that how do we manage demand and supply, right? What kind of pack are you putting up? As we're talking about, let's say if you're putting up a gigawatt kind of solar capacity, what is the amount of battery that is required? How can we manage with the least quantity of batteries going in there? So all of these parameters are important, and more data is required on the last part. More research is required on reducing the upfront cost and increasing the life. But the target is to reduce it below 4 rupees, as I mentioned. And I think Rahul can add more color to it and more precise information. But as per our understanding, anything less than 4 rupees as a storage cost, additional storage cost beyond generation cost, is something which will disrupt the market.
If there is stability in geopolitics, 2027 is a good point of what you want, you'll get it.
I like short and straight answers. Thank you.
sir, if you look upon other than the battery, if you look upon other options like what we have talked about, chilled water storage or hot water, even today it's cost less than 1 rupees per kilowatt hour. So
I think Rahul would like to answer part of the question that you had raised.
No, I just feel that again, in terms of the numbers and in terms of the year, I feel even right now we can get to that price point if there is a right application where you use multiple cycles per day, because there are technologies which can give 10,000, 15,000 cycles. So actually you don't need to wait for cell prices to go below $100. You can even with $200, $250, if you have large enough cycles and you find the application where you can use those cycles, you can get to that number. But the key part I feel is again, the message at least I want to give it is we don't need to wait for 4 rupee per kilowatt hour. There are enough applications right now, as Professor Junjunwala mentioned in the morning. Right now, the research park and every other commercial customer is paying 11 rupees per kilowatt hour. Why do we need 4 rupees as a threshold for adopting this? I don't understand, because while you are waiting for it, every day, every hour, every kilowatt hour you are consuming, you are paying 11. So anything which is less than 11, less than 8, you should start adopting that, because there is nothing happening on the grid side to bring down the cost of electricity as a delivered cost below 11 rupees. If someone is imagining that, then we are living in a completely dream world, and that's not going to be possible. So we should be actually not waiting for, because something is going to be available in 2 years, 3 years for 4 rupee, 5 rupee, because that's what we have seen as a very easy thing for doing inaction is to just keep on waiting for something. Like you don't do it for your cell phone, for your laptop. You know there is in 1 year, 2 year, there is going to be better product available, cheaper product available. But if you can get more productive use of it right now, let's just do that.
Just want to add one point. Back I lived in California. See, we used to get the money back from when we had the solar panels. It's a small panel, right? Which is the rooftop solar. That also play a critical role to reducing the overall cost and also supplying back to the grid. After in turn we are getting money back. So that applicable to every form of house in India, right? So we have enough rooftop that also potentially give it back and take it from them. So that's also a good thought, but at policy level it will happen unless India, nobody listen unless it is dictated, right? So that's opportunity we have.
In some sectors today, for example, in the dairy industry, there is a viability gap funding available. And that industry potentially has storage opportunities as well. But the real challenge is there are no integrators who can offer that solution in large scale as well. I mean, we have experimented to pilots in Amul, and we need startups to scale them. No, we are not a contracting company. So people with the business model innovation, there's already a lot of money on the table to take it actually. So we need a lot more integrators, and that's another area where we have also been challenged. I mean, taking the example, I mean, India today has got a lot of residential air conditioners being sold, especially in summers. But we don't have the skills to commission all of them. You may have a 5-star rated air conditioner, but if you don't commission with the right piping and infrastructure, you don't get the efficiency that is declared on the label as well. So we have another dimension of problem as well, which we need to simultaneously handle. Is just that we need to keep in mind. So therefore, this whole partnership for goals is something IESA should promote, is also my suggestion to Rahul.
We're already working on that.
Thank you.
Thank you to all of you. Thank you for the excellent insights. I'm sure a lot of takeaways that each of us have got, the entire room has got. For the paucity of time, I'll not be able to take any more questions, but I'm sure the panelists will be available during the break, during the evening, if anybody wants to have a one-on-one interaction. Thank you so much.